In this final video clip, I will discuss signal alignment. As was touched on in an earlier clip, the flow measurement for breath is obtained from the small differential pressure created across the PTAC screen. This differential pressure travels at the speed of sound and hence is detected almost instantaneously in the S147. The gas signals, on the contrary, being pumped at 300 mils per minute down the sample line, take about 0.8 seconds to reach the gas analyzers in the S147. Now it's absolutely critical that the gas signals be aligned with the breath flow. The reason is, in the calculations, to obtain oxygen and carbon dioxide flow, and hence their volumes, the respective gas concentration is multiplied by the flow sample corresponding to that concentration. The flow and the carbon dioxide have been aligned at qubit to the oxygen signal using a fast pulse of high pressure cal gas, or 5% CO2 and 16% O2 cal gas, which is, by the way, very similar to exhale breath. The instrument should not need realignment of the signals in the field. However, I'll show a procedure here by which you can periodically check the alignment with a sharp puff of breath. So we'll actually do that now in the Logger Pro screen. So I will breathe and give a small puff of breath into the face mask. It should be noted that before you give the puff, you should partially exhale to clear the dead volume in the airways and the mask. So I'll now give a sharp puff of breath, just a very small puff. On this plot, I show both delayed and undelayed values. For example, the undelayed flow is indicated by the gray squares, whereas the delayed flow is indicated by the black dots. Similarly with the carbon dioxide, the undelayed values are shown by the dark squares and the delayed values by the lighter dots. If I put on a cursor, you see that the delayed value of the flow aligns to about the middle of the transition in the gas signals. The total delay includes both the transit time down the gas line, as well as the response time of the gas sensors, which is of the order of 100 milliseconds, 6 or 7 channels. So this total delay has been determined, as I said earlier, with a gas pulse at qubit and entered into the calculations. You can see this delay. It was entered as a parameter which you can observe under the data menu, and if these values have changed significantly, you can change them to match your new signal alignment. So in summary, hopefully this video has, in combination with the instrument manuals, will provide a working knowledge of the system. Any questions not answered here hopefully can be dealt with by the qubit staff. Background information on the field of respirometry can be obtained from the introductory section of the user's manual, as well as from the references listed there. Finally, Simple experiments outlined in the appendix of the manual are intended to provide the user with a means of becoming familiar with the operation and capabilities of the apparatus. In conclusion, we hope you have many enjoyable hours of research or teaching using this Qubit breath-by-breath instrument. Thank you for your time.